Tension in strings, that should be an N, strings, we're going to have both edges, but our situation is going to involve translational equilibrium, which basically means the object is going to be, or all the objects have to be moving with a constant velocity. Let's get our situation drawn out here. So we're going to have a tabletop. You're going to have some objects. This one will be a 3 kilogram object. It'll come over the edge of this table. There's the pulley to 6 kilograms. And that one will be 7 kilograms. Make it a table there. Okay, so that's your situation. What we want to do is we want to figure out the coefficient of friction, which is going to keep it in translational equilibrium. If you have something with a constant velocity, you just need to remember your acceleration is going to be 0 meters per second squared. Okay, by remembering that, that's going to be a big help. What I'd like you to do now, I want you to push pause, and I want you to try to figure out the coefficient of friction that's going to keep this entire system moving at a constant velocity. Okay? Okay, hopefully you pushed pause and gave it a try. Let's see how you did. First thing we're going to do is make this thing our linear situation. So we're going to have our 3 kilogram object. We're going to have a tension here. Call that one tension 1. You're going to have your 6 kilogram object being forced this way. 6 kilograms, downward force 60 newtons. You're also going to have a tension 2, 7 kilogram object, and it's going to be going this way with 70 newtons. We need to figure out 70 newtons here, 60 newtons there. Is this thing going left or right? It is going left, so we're going to make the left hand the positive direction for ease. And that means that your force of friction here is going to be force friction. There you go. Going in that direction. Okay, so there's your first step. Your second step is going to be to remember if that we're doing something that's got a sum of forces, constant velocity, or acceleration being 0, then your sum of forces has to equal 0. Not, well, you can't say mass times acceleration, and we'll do that, and then we'll just cross it out after. So let's see here. We're going to go 70 is going to be subtracted from, or added to rather, the negative force of friction, which is going to be added to negative 60, what should equal ma, but since a is equal to 0, I'm going to cancel this all out to 0. Okay, so 70 minus my force of friction minus 60 equals 0. 70 minus mu Fn minus 60 equals 0. So 70 minus mu normal force is only going to be on the 3. So that's going to be 3 times 10 minus 60 equals 0. 70 minus mu times 30 minus 60 equals 0. I'm going to solve this thing all out now. I'm going to bring over the 60. So let's go mu times 30. Mu times 30 is going to be equal to 60 minus 70. So mu 60 minus 70 over 30. That means you're going to end up with over minus 30, because this is minus right here. That's going to be minus 10 minus 30. So your mu value is going to be 0.33. That is the coefficient of friction required to keep this thing moving at a constant velocity with an acceleration to 0. Could have a constant velocity of an actual value like 15 meters per second, or it could have a constant velocity of 0 meters per second. It doesn't matter. Fact is, it's our old equilibrium stuff where it's equal to 0 with our new kind of setup. So there you go.